Hey guys, welcome to the video tutorial for Hooke's Law type problems. The problems that you'll primarily encounter are going to involve masses that will be suspended from a spring. And so you might have a problem where you have a mass, let's say this mass is like 500 grams. Okay, and let's say the spring has an initial length L1 of let's go with 15 centimeters. Okay, and let's say that after the mass is attached and it bobs up and down for a while, it reaches equilibrium, and the spring now has a new length of let's go with 25 centimeters. And so from that, let's say we're on Earth, so G is 9.8, you are asked to calculate the spring constant, K. Well, we know that Hooke's law says that my elastic force is equal to negative Kx, where where x is how far the mass is stretched from equilibrium. So when we think about that, we know x is 10 centimeters. It's just 25 minus 15. But since it went down, I'm going to say it's negative 10 centimeters. And going from centimeters to meters, I divide by 100, so that's negative 0.1 meters. Now, as for my elastic force, at this point, when the mass is suspended down, my block is in equilibrium. In other words, my F elastic equals my weight, which is Fg. So what I can do is set those two equal to each other. So in other words, I've got Fg equal to F elastic. And we know that Fg simplifies down to mg. That m got away from me there. Mg. And that equals negative Kx. Well, I know m is 500 grams, but I need to go to kilograms, so that's 0.5 times g, which is 9.8. And that equals negative k, and x is going to be negative 0.1. So those negatives are going to cancel, so 0.5 times 9.8 is 4.9. And then that is going to equal K times 0.1. So I'm going to divide both sides by 0.1. So I'll get a K equal to 49 newtons per meter. 49 newtons per meter. So that's if you have a hanging mass. Now let's say that you've got a mass, or you've got a spring, but it is a horizontal type spring. And let's say that I have pushed this spring in a distance of, let's say, 0.3 meters. And I know that the spring constant K is, let's say it's 50 newtons per meter. And I want to know what force I am pushing with. Okay. Well, if you think about it, I have stretched it, or I have compressed it in the negative direction. So I'm looking for F elastic. Now, F elastic is going to be going to the right. I am going to be pushing to the left. So what I can do is just find F elastic using negative Kx, and then just negate it. So in other words, F elastic equals negative 50 times 0.3, and so my F elastic is equal to 50 times 0.3, which is 15, but that is, this 0.3 is going to be negative because it's in the negative direction. So I have negative displacement, which means my F elastic is in the positive direction, which makes sense because that force is always back towards equilibrium. So that means my F elastic is 15 newtons per meter, which means that I am pushing with negative 15 newtons per meter if I want to hold that mass at that point. So those are some example problems of dealing with Hooke's law.